I'm really glad to be here with you. I'm learning a lot myself and enjoying also uh, from the presentation so far. What I'm going to try to explain is a prototype type of simulation we are building as part of a large research proposal to create what we call it Advanced Disaster Simulation Lab at York University. And that's because York University is one of the only two universities in Canada that has disaster and emergency management program. In fact, we have the largest in terms of number of undergrad and graduate students, and we are creating our first Ph.D. disaster and emergency management in Canada, hopefully very soon, next year. And for that purpose, we are hoping to get deep into AnyLogic using the professional version, hopefully next year. If we come together again in the next conference, we would be able to see if we were successful with that funding. I hope so. And we would have the professional version at that point too. And as an introduction, I'll provide you why I'm using, and I'm in AnyLogic user right now. A problem that we are looking at this morning and what this demo or prototype model is trying to do, it's basically toward what we call it dynamic risk modeling, not only for the purpose of risk assessment, but also for disaster preparedness and planning. And a bit of the details of this application, AnyLogic application, and a demo at the end with some notes about what we are going to do next. As way of introduction, I just would like to mention that I'm really glad to see AnyLogic 7 because of so many reasons. I was using, for those of you who are, and I'm sure many of you are, I was using Dynamo, DOS-based software to create dynamic models during 80s. Some of you might have used that also. And I was using ArcInfo back in 80s again. That was probably the earliest version in DOS again. Very difficult, complicated. You have to type all those commands, and learning process was quite something. And then just recently moving into agent-based modeling. Now, I had always this dream of being able to combine system dynamic with GIS. I tried, and sometimes it works, but you had to couple them in a very complicated way. And on the other hand, once you're talking about agent-based modeling, especially in our environment or the discipline I am working, it helps, but it's not helping a lot if you don't have good GIS support for it. So I had to go back and forth between GIS and agent-based modeling if I didn't want to use repass or agent analyst with ESRI, which were also difficult. So when I have AnyLogic 7.1, and it happened just a week, probably late, when I just finished this model, but I tried to convert it to this new version. But anyways, I mean, I'm really glad to see this, and that's why I'm using. This is, in my view, the best tool that you can integrate all those things together at one time. That's why I'm using it, based on my experience and based on what I have gone through in all those past years. So I see this is a natural progression of the software. That is what we have today, and I'm hoping to see even more advancement on that. So the problem starts with this. Really, in 2013, July, there was a big event in Lac Megantic, town of Lac Megantic in Quebec. In this disaster, about 40, close to 50 people died. There was a train derailment carrying crude oil from North Dakota to eastern Canada. And there were lots of problems, and I'm not going to explain why this train derailed and what happened in detail. But as one of the first experiments, very, very simple experiments I did with AnyLogic was this, that I also posted online. If I can run this. It's just to explain the problem, not really the power of this simulation. This train had about 72 or 5 tanks and had 4 locomotives. Locomotives derailed, and it was almost 1 a.m. at night, and about 40 of these tankers were leaked, and you had a large fire, an explosion there. And it took about up to afternoon of that day to finish fighting this fire. And of course, the whole downtown part of this small town was burned to ground, basically. And now, this was my first, as I said, type of simulation I did with AnyLogic. And I always wanted to have a GIS background in it. This is now an image, but of course, if you are able to interact these behaviors and activities, emergency response operations with a map that you can work with, that would make it much more powerful. And so that's where I'm coming to this. So this is just a simulation of what happened. It has not much really activities behind it. It's just because I wanted to simulate the event. Back to PowerPoint, please. Yes. Now, every day there are lots of trains carrying hazardous materials in Canada and US. These are some of the recent events just for trains carrying crude oil, not all other hazardous materials. And it's very evident that recently there has been an increase in these events. I mean, partially is because of the huge volume of oil transportation through the rail, and also because of the fact that the pipelines are limited. They need more investment, long-term investment, but these are quite easy and accessible. So that pressure on railroads has increased, and because of that, we have more incidents like this. These are just some of them. Lac Megantic. The point with Lac Megantic was because of the extent of the disaster and the fact that it is now one of the world, basically, largest and severe disaster, train derailment disaster. Soon after that, there was lots of discussions in Canada, in US, and all other countries, how we can mitigate these type of train derailment, which is, of course, an important issue. And now, as I said, the reason behind this is in part because if you look at the even recent statistics, in 2008, you were talking about 9,500. This is the average crude oil rail carry annually. These are, and then you can scale it and see what is the same amount in 2013. That is, you can guess what the change is. So we are talking about this, and this is going to increase even faster in the next couple of years, and so this is the pressure on, and this is, as I said, it was only crude oil. We are talking also about lots of other materials. And because of Lac Megantic trail derailment, what happened was that government of Canada decided to put pressure on rail companies to provide hazmat information to municipalities. That was one of the few actions they took to somehow mitigate this type of events in the future. And there were, of course, this was because of the municipalities pressuring the government, and that happened. But my question to all municipalities at that point was, okay, suppose you got this information, what are you going to do with it? Can, for example, a small municipality like Lac Megantic or all other smaller towns and even larger cities have the capability to use this information in an easy way? That's the difference. There are tools, but none of these emergency managers necessarily have the capacity to run and analyze them. So my solution, not an institutional solution or a solution that we are in our discipline looking at, is kind of looking at it from risk management perspective and trying to identify how we can reduce this risk through identifying those peaks or spikes in risk management. So we came with this dynamic risk modeling. Of course, most of you, I'm sure you are aware how we can, or what type of variables in such type of analysis we have. Some of them are static, some of them are kind of semi-dynamic, and some of them are real dynamic. So we are dealing with a situation, we want to model a situation where some of our variables are real dynamic. And there are so many examples of why we say this is dynamic. This is just one example. The weather impacts a lot in what trains are transporting. The very good example was yesterday. We had an interesting example of the changes that happens in pipelines when carrying crude oil also from one end to another end. The same here when they transfer. In fact, this was in July, so that was the peak. And one of the reasons they say was because of the extent of damage was actually the weather, because it was hot summer, and the materials actually changed during this trip. By the time that they reached Lac Megantic, they were quite different in terms of flammability of the materials. So this is really dynamic. And also you're talking about dynamics in people, population level, and all other attributes. Now, for this, we try to use very simple, but still this is in progress. I can't claim that these probability figures that we have reached are the final numbers that we can work with, but I use the literature to find out how we can, or what would be the best measurement of train derailment probability for different segments of the rail. That's what we used, and we calculated the probability of derailment based on this past research. And you also need to, when you do risk assessment, you also need to calculate the exposure. In this study, although we consider all assets that are impacted, but our focus was mainly on human exposure, because that's the most important key decision making in this regard. Government of Canada, same as US, they have some standards of how much would be the exposure area or impacted area for different types of hazardous materials, whether it is daytime or nighttime. This is for major spills, because we are not really looking at smaller spills where normal emergency operation can take care of. But these are for larger spills where distances are usually high. So looking at this, there are about 600 some hazardous materials carried through this, or potential to be carried through rails also. And for each of them, you have these, what they call it, on those three last columns, you have the isolate impacted area or immediate impacted area. For example, for chlorine is 1017 is 500 meters. For the very immediate impacted area, this area has to be evacuated, or people who are in that area might be severely impacted if there is a derailment of this type. And so with some, and the other numbers are in kilometers. So you have 500 there, 3 kilometers, and 7.9 kilometers. This is our base for calculating the exposed or impacted area. And of course, for smaller spills, the downwind is an important factor, but for larger spill, you have to consider the whole like buffer zone around your derailment event. So the overall dynamic risk model would be kind of multiplying your derailment probability by your population at risk at any given point at any given time. That's what we are putting together here. And now, why we choose Toronto? Of course, this could be applied to any other city, and that's our intention. This is not just for Toronto. We chose Toronto as a prototype because we are in Toronto, and also I had better data for Toronto. And in fact, because Toronto is the largest city in Canada, the risk is much higher in the city as well. And already lots of councillors and others are asking for some change in this. This is one of the rail line I'm focusing on right now, but it could be all different railroads inside the city. So already see councillors are asking. This happened, of course, after this event. And now, this application I'm working on, as I said, it includes all those hazmat chemicals. It doesn't mean that all trains carrying this. Some trains, at some points of time, they carry this, not necessarily large volumes in tankers. Maybe one tanker over 100 cars is carrying hazmat materials. So you have some agents here. But these are just some of them. You can add as many. And in fact, based on demonstration I had with the city emergency managers, they provided some good feedback. I'm going to add some more. But it is just a capability. You can add as many agents as you want in terms of type. Here I have, for example, ambulance services, fire station, police services, hospitals. You can add long-term care facilities, whatever you like, of course, as you know, you can add. But I have shape files for all of these. I convert them to lat and long base and with their attributes into a text file, CSV file, and then create those agents. And now that you can have actually, if you have all this information within your OpenStreetMap, you can read from there. But my test was not showing exact results. If you do it by OpenStreetMap, for example, you get like 50 schools in Toronto, but here I have like 550 schools. So that's why I'm using the actual city information. And to calculate the day and night population, I had the night population, which is assuming the census data is night population. I had the employment number for different districts in the city, and I estimated kind of daytime population based on the employment level in the city and different districts of the city. And some of these agents are agents related to the actual hazard, like train, like plume, like particles, or fire itself. Now, this is a simple demo of inside, for example, the population agent. This is basically an impact as distance, as train enters that particular place. So it changes the state of one agent from being normal to impacted at night or impacted at day, depending on what the material is. And this information, of course, is read through that text file and also passed into this is another example of the train agent, where I have data again coming from that table that I showed you with lots of columns, but some of the key variables here are these, and interactions with other agents through that distance. This information is also passed through dynamic variables to my Excel file as a database, and I can transport and use those also in ArcGIS for other activities. Now, this is a typical result you get, for example, for petroleum. If you have a train carrying petroleum and there is a major leak, this would be the day and night impact. And as I said, we are interested really on those peaks. And if we can lower those peaks, we would be able to change the whole dynamics of risk management in a better way. So those lines you see are averages for day and night. And just by changing some of those upper level peaks, you might be able to minimize the risk quite significantly. And when I showed this introductory results to the City of Toronto emergency managers, they said, basically, we would love to have this for each ward, because our counselors, if they see these results and this simulation, they would jump into that. That's what they need, and that's what they can convince others to take some actions. So this is the structure of the interface of the model. On one hand, you have the setup, the simulation setup. On the other hand, you have the basic results. And of course, you can see all other results in different formats if you like, but this is what is very simple and what they can see. You have all the agents. You can show them, turn them off, and also you can run your simulation based on default values. That is what is provided by the Department of Transport. And also you can change the distances based on your expertise and what experts tell you to change. So you can change and see the outputs. And I'm adding to that some more functionalities, but if you can please run, and as I run this, I explain some of these attributes. I was not sure if I can use my laptop properly. My laptop is really heavy in terms of the data that is in. Sometimes it crashes, and I don't want that to happen here. So this is crude. I think this is crude oil. I can see it, but this is a demo of that. So you load your hazmat train. This is basically when this train enters the city or nearby, and you load all your layers if you want. You can turn them on and off. This is ambulance, for example, and you run the default. This is the default. This is in higher speed, so still is slow because train is this train is moving really fast right now. So as it gets near the city, of course, you see the impacted population based on those figures, and on your right, you have the risk levels by numbers, and also the impacted population by graph. And you have all those tools. These are GIS tools. You can zoom in, zoom out, left, right, and up and down. You can zoom into particular location of the train as it moves. You can zoom in and see the real path of the train. I think I have some. Yes, you zoom in. I had the same issue with regard to the proper location of rail track sometimes, but you can adjust that, of course. So here you see the color changes. These are, by the way, the lowest level of census tract. These people are each indicating the lowest census block. Sometimes they have an average of 500 people, 300, it varies from place to place. And this also calculates schools. This case, I think the icons you see are schools that are impacted. So if it is daytime, it considers that impact. If it is nighttime, it also includes that impact. You can watch that, but I explained the other options here. What I'm trying to add to this is one area that is for the derailment, because we are interested, for example, emergency managers are interested in knowing what would happen if derailment actually happens in this particular point. So you make the derailment option. it derails, whether it's night or daytime. When you push the derail button, then you see the simulation like that stops, but you will see the number of people, in this case households, that are within that threshold or impacted area. And then I'm trying to simulate that evacuation from that particular impacted area. So I don't need to evacuate the whole city or whole, that unspecified area. In the other hand, I just focus on that impact zone and try to add those people as agents and work with them just to simplify and lower the. So I think that's where I stopped the simulation for derailment, assuming that a derailment happens here. Then you can create zoom out a bit and add. This is the wind direction. If you want to have particular wind direction and see who are the people within this wind direction level. I mean, this is also similar, kind of visual into this event, but I'm working on it. It's not final, but you zoom in. These are the actual household that are living within that particular impact zone. So you can actually simulate that the evacuation process. Can I stop this and move on to the next slide, please? Yeah, that's enough. Yeah, thank you. Yes, future works. What is missing in this is that the dynamics of day and night population is just one option. You have day and night. What I'm trying to do is to make it more dynamic so that at any given point of time and day using a function, you have the actual number of people in that particular day for time. For example, if it is 8 in the morning, you have the actual or estimated number of people based on that. And I'm also, as I said, I'm adding the evacuation and shelter planning to this. That's in progress. Also adding risk mitigation scenarios. As I said, if what would happen if you, for example, change the direction, change the train time, and so on, would you be able to mitigate the risk based on these basic key policy options? And also more intelligent into model. For example, if for different types of hazmat, you can have the characteristics of hazmats and build it into model so that when something happens, you can have different dynamics and visualizations of the type of the impacts you might have. And also train specifications. This train, as you see, just was 4 iconic tankers, but you can actually model the whole train using it as an agent. People can choose if this train has, for example, 10 cars, 20 cars, or whatever, and which car is going to be derailed. These are possibilities to be added to this. And I stop here and leave some space for questions. Thank you very much.
Thank you very much. I just couldn't remember when you were talking earlier, did you talk about what is the proportion of derailments that result in rupture in the skin of the car, resulting in actually release of toxins?
The rate is really low. I have some numbers here. Comparing, for example, to road, there are more number of train derailments than, for example, road and also the pipelines, but the portion is very low. I mean, the number is quite low. I don't remember on top of my hand, but this is very low. But overall, the thing is that when something like this happens, the impact is quite high. That's the difference. But this is really low.
Have you considered putting the type of container car in? Some cars are better at containing spills than others based on the thickness of the hull as a factor in the likelihood of a spill when there is a derailment?
That's a good question. In fact, that's possible. As you can see, the train specification is kind of important. I think That's what also the government of Canada and also the U.S. Decided to change after this because of the actual type of the train, the containers or tankers. They were not really high quality, so that in any case of derailment, they leak. So they have actually requested stopping transportation of crude oil by these particular type of tankers that they were using so far. Unfortunately, there's still lots of them are lots of rail companies are using this still, but the regulation is going to force them to change quite fast. But for now, still like 70% of crude oil is transported by these kind of regular tankers.
Thank you very much.
Thank you.